Currently, more than 128 million objects larger than a millimeter are orbiting the Earth. They've transformed the space around them into a junkyard. These objects range from inactive satellites to flakes of paint. Even a millimeter of this junk traveling at very high speed can wreak havoc. It can be catastrophic to various satellites connecting us around the world. In reality, a fleck of paint was enough to damage a window of the International Space Station in 2016. Where does all this space junk come from? Why is it dangerous? And most importantly, what are we doing to get rid of the space junk? When we watch TV, use GPS, or check the weather, we either directly or indirectly rely on satellites. We often ignore the services that satellites provide us. Satellites deserve our attention and are leaving a lasting mark on the space they occupy. Satellites we rely on for entertainment, telecommunication, and connectivity have a finite life. They might malfunction, run out of propellants, or they may just naturally reach the end of their mission life. At this point, these satellites effectively become space junk, cluttering the orbital environment. The first satellite was launched in 1957, and in that year, there were only a total of 3 launch attempts. Decades later, and dozens of countries from around the globe have launched thousands of more satellites into orbit. In the future, the frequency of launches is only expected to increase. There is roughly a possibility of 900+ satellites being launched. We send satellites to various locations based on mission goals. One of the most common places that we send satellites is LEO, or low Earth orbit. It is up to 2,000 kilometers in altitude, and most satellites in this region capture the image of the Earth. Satellites in this region have a decaying orbit due to friction caused by the Earth's atmosphere, so these satellites can burn out within a couple of decades. Another common place where we send satellites is the geostationary orbit. This is located at about 35,000 kilometers in altitude. Satellites there remain at the same place as the Earth rotates. This enables things like communication and television broadcasts. They can remain there for centuries. The third orbit is called the graveyard orbit. This is an eminent junk or disposal orbit. With time, the number of satellites in these and other orbits will continue to increase. All this space traffic can lead to a disaster. The first documented collision involving space debris happened back in 1996, when a French satellite was struck and damaged by debris that had exploded a decade before. In 2009, there was an unintentional collision with a commercial satellite from the US and an inactive Russian communications satellite named Cosmos 2251 at the speed of 22,300 miles per hour. The collision resulted in 2,300 pieces of space shrapnel, which now pose a threat to other spacecraft. Now, with tens of thousands of satellites traveling at 17,000 miles per hour, the chances of these satellites getting close to each other are a lot higher. There is larger debris, like the massive upper stage of Apollo 12's Saturn V rocket. It is still in orbit and is expected to return within the next few decades. But this material is easy to dodge as space is a big place. In 2019, after a few weeks of India's anti-satellite test, a decent amount of debris is scheduled to fall to Earth. It can be compared with Operation Burnt Frost, the US-owned anti-satellite test in 2008. There are glaring similarities between this and the Indian anti-satellite test. Data from the combined space operations showed that the majority of debris from this test had fallen back to the Earth within 2 months, while other pieces managed to be ejected into higher orbits and will eventually return to the Earth within 2 years. This is the case with larger trackable debris. Their decay is faster as it has a larger area-to-mass ratio, making them more sensitive to atmospheric drag. Even in orbit, molecules do exist that collide with satellites and debris, causing them to slow down and lose altitude. Collisions between high-speed objects in orbit can create thousands of pieces of debris. It could easily start a chain reaction, creating more and more junk. Kessler syndrome also dictates that as the number of satellites in Earth's orbit increases, the probability of collisions between satellites also increases. It starts a chain reaction, and eventually it will become a death trap for future missions. Further, Dr. Kessler states that the processes that produce these fragments in space could be similar to how the asteroid belt was formed, but it will take a much shorter time. He has termed this a debris belt, and if it turns into a reality, no space mission will be possible in the future. This is how dangerous space debris can be. But whose fault is it? Is every country equally responsible for generating space debris? Or can it be termed NASA's problem? Well, countries don't generate an equal amount of space junk, so the United States' stake in space is greater than any other country in the world. For example, NASA paid half of the $100 billion for establishing the International Space Station. This portion is larger than the contribution by all other countries combined. So, we can say space debris is NASA's problem. From a capitalistic point of view, NASA holds more property in space than any other country in the world. Obviously, NASA knows about this, and they started research in debris removal in the early 1970s. How can we stop this orbital junk from generating a chain reaction? The problem can be addressed in two ways. First, we must stop polluting space, and second, we must remove the space junk. Dragging space junk into the Earth's atmosphere will work for smaller objects as the frictional heat of re-entry will burn them up. The European Space Agency's Clean Space Initiative began developing missions in 2013, and currently, the ESTEC Center in the Netherlands is developing eDeorbit, whose main objective is to deorbit satellites at the end of their lives, preventing the future creation of space debris. The task is to safely deorbit a derelict ESA-owned satellite in highly trafficked low Earth orbit. Its target is the Envisat Earth observing satellite. It was chosen because it failed unexpectedly after being in operation for 10 years. Another approach involves using nets to capture space junk. The concept is inspired by what fishermen do and traps the debris using a very large net. The European Space Agency has also awarded another contract to ClearSpace to retrieve 220 pounds or 100 kilograms of rocket debris that has been orbiting the Earth. ClearSpace, a Swiss startup, has been working with ESA and the UK Space Agency on the development of its own space junk removing spacecraft. The company's first attempt, ClearSpace 1, is planned to launch in 2025. The tentacles of the spacecraft will grab Vespa, the upper stage of a rocket left behind in 2013. Then ClearSpace 1 will bring it down into the atmosphere, where both of them will get destroyed. Further, SpaceX has also devised an innovative idea to clean space. They're planning to trap the space junk using starships. Similarly, in 2018, Remove Debris was launched, a satellite research project intended to demonstrate multiple space debris removal technologies. The mission is designed to test the efficiency of various active debris removal (ADR) missions in a low Earth orbit. The microsatellite called RemoveSat will release and capture several targets called DebrisSats. The mission hopes to find the best way to capture 40,000 pieces of space junk. If the problem of space debris continues to grow as our space activities grow, the potential loss of money from damaging collisions and the potential chain reaction will force us to fix the problem. It's not just the cost of the satellites that will motivate efforts to clean up space debris. Entire economies are built on the services they provide. The international telecommunication and broadcasting industry will suffer a lot as a result of increased space junk. In recent times, a few international treaties have dictated that space operations must be updated to mitigate this issue. It ensures that any satellite sent into Earth's orbit must be capable of bringing itself out of orbit and dodging debris when needed. In the meantime, efforts have been made to ensure that new satellites don't add to the problem. Ideally, satellites will be sent into the graveyard orbit or course-adjusted to re-enter the atmosphere at the end of their lifespan. This alone is not enough to ensure debris is kept at a reasonable level. How will countries respond to the issue of increasing space junk? Will Earth's orbit become unusable, or will space agencies be able to tackle the waste? Only time will tell.